In this video, you will learn how to solve equations by adding or subtracting. Now, when we say equation, we need to know what we are referring to. So an equation is simply a mathematical expression with an equal sign. So for example, x plus 7 equals 15. So that would be an equation because you have an equal sign connecting two different mathematical expressions. Next we have the word solution. A solution to an equation is a value that can be substituted in place of the variable to make an equation true. So in the example x plus 7 equals 15, the solution would be 8 because 8 plus 7 would equal 15. Now, to illustrate how we can solve equations, we need to understand the addition property. So let's say, for example, you are playing a basketball game and the game is tied 26 to 26. So if both teams score 10 more points, the score will still be tied, right? If I add 10 to both teams' scores, it's going to be an equal statement. So the addition property of equality says that given an equation, so if my equation were 26 equals 26, I can add or subtract the same thing to both sides to keep a true statement. So in this case, I added 10 to both sides, and the statement remained true. So we have the addition property, as we just stated, which says we can add the same thing to both sides. So this is, in mathematical notation, this is the same thing that we just discussed. So if you're given a and b and c as being any real number, and a is equal to b, then I can add anything to both sides. So I can add c to both sides and still have a true statement. So I have a plus c would equal b plus c. And also I can change the order of addition. So instead of a plus c, I could have c plus a. And instead of b plus c, I could have c plus b. So bottom line, you can add the same thing to both sides of an equation. So if the same number is added to equal numbers, the sums are going to be equal. And the same thing is true with subtraction. I can subtract the same thing from both sides. So if a, b, and c are any real numbers, and a and b are equal, then a minus c would equal b minus c. So bottom line, if the same number is subtracted, then your answer will still be the same. So I can subtract or add the same thing to both sides. Next, we need to understand what an inverse operation is. An inverse operation is an operation that undoes another operation. So some examples. Addition and subtraction would be inverse operations. If I add 4 and then subtract 4, I'm right back to where I started. Adding and subtracting will cancel each other out. Now with multiplication, the inverse operation would be division. Those two operations undo each other. Now this is important to understand as we begin solving equations, because to solve, I need to do an inverse operation of some sort. So here we have x minus 9 equals 17. So here we see minus 9. We're trying to figure out what is x equal to. So I need to get x by itself. My goal is to find what is x equal to. So at the end, I should have something like x equals and then the number on the right side. So we need to get rid of this minus 9 with the x. So to do that, I do the inverse operation of subtracting 9. So instead of subtracting 9, I'm going to add 9 to both sides. So we see here I'm adding 9 to the left side and adding 9 to the right side. And I do that because negative 9 plus 9 will cancel each other out, and that will give me 0. So now I have x plus 0, or x, on the left side, and on the right side I have 26. So my solution would be x equals 26. And I can double check to see, is this true, by plugging this number back in for x. So if I plug a 26 back in for x, instead of x minus 9 equals 17, I would have 26 minus 9 equals 17. And is that a true statement? Well, 26 minus 9 is 17, so that is a true statement. So therefore, yes, 26 would be my solution. Here is another example. Negative 4 equals n plus 12. I need to solve and determine what is n equal to. So I need to get rid of the plus 12 so that my final answer will be n equals something. So there should be nothing here on the left side, or whatever side the n is on. So here the n is on the right side. I'm doing the same thing. I need to get rid of the 12 by doing the inverse operation, and that will move the 12 away from the n, so n is by itself. So what is the inverse operation of adding 12? Well, that would be subtracting 12. So if I subtract 12 here on the right side and subtract 12 here on the left side, on the right side the 12 minus 12 will cancel. 12 minus 12 is 0. So I have n plus 0, or just n, on the right side. And then on the left side, I have negative 4 minus 12, which would be a negative 16. So my final answer is n equals negative 16. And I can change the side that the n is on. I can move it over, so it's n equals negative 16 instead of negative 16 equals n. And that would be your symmetric property. And we can double check our answer by plugging negative 16 back in for n in the original equation. So here we had negative 4 equals n plus, that should have been a 12. Alright, so n plus 12. We plug negative 16 in place of n. So I have negative 4 equals negative 16 plus 12. Is that a true statement? Well, yes. Negative 4 would equal negative 16 plus 12, which is also negative 4. So it is a true statement. It works. So negative 16 would be my solution. And a side note here, there's a term to know, and the term is equivalent equations. All this means is that we have two equations that have the same solution set over a given domain. So for example, x minus 9 equals 17. That is an equivalent equation with x equals 26. So in that first problem here, x minus 7 equals 19. That is the same or equivalent equation as x equals 26. So just a term to be aware of as we progress in our study of algebra. Next, we have to solve this equation. Negative 19 plus b equals 24. So this one looks a little different because the negative 19 is in the front, but notice it's being added with b. Alright, so negative 19 plus b equals 24. So to get rid of the negative 19 that's being added, I need to do the opposite of this. So this is kind of like b minus 19, b plus negative 19. So to get rid of the minus 19, I need to add 19. So I'm going to add 19 to both sides. So when I do that, I have negative 19 plus 19 on this left side, and then 24 plus 19 on the right side. And notice when I add 19 with negative 19, that's going to cancel out. So that's why I chose the plus 19, because that cancels leaving me with 0. So b plus 0, or b, would be on the left side. And then on the right side, we have 24 plus 19, which is 43. So my solution is 43. And I could double check by plugging 43 back in for b. I would have negative 19 plus 43, which would indeed equal 24. So that solution is correct. Next, we have negative x plus 6 equals 4. So this one, there's two things going on. We have a negative and a plus 6. So we want to get rid of both of those because our end goal is to get this to look like x equals something. So positive x equals something. So let's get rid of the plus 6 by doing the opposite, which would be subtract 6. When I subtract 6 on the left side, 6 minus 6 will cancel. That's going to give me 0. So I have negative x plus 0, and then, or just negative x. And then on the right side, 4 minus 6 would give me negative 2. So negative x equals negative 2. Well, we can just look at this equation from here. If we replace the x with a 2, we would then have negative 2 equals negative 2. So x would have to be 2. And we could double check by plugging it back in. So if we plug a 2 in for x, we'd have negative 2 plus 6 equals positive 4. That is a true statement, so we do have the correct solution. There are times, as you see right here, where we might need to simplify on the left side first before we start solving the equation. So here we have b minus 4 plus 19 equals 102. Well, the parentheses we can just actually get rid of because it's being added with the 19. That is the same thing as b minus 4 plus 19. So negative 4 plus 19, or 19 minus 4, would be 15. So on the left side, we now have b plus 15. And then on the right side, we have 102. So now from here we can solve, do the opposite or inverse of adding 15, which is subtract 15. So I subtract 15 on the left and the right side. 15 minus 15 would cancel. That gives me 0. So I have b plus 0, or b, on the left side. And then 102 minus 15, which is 87, on the right side. So my solution would be b equals 87. The next one, we have the absolute value of x minus 3 equals 8. So same thing, we want our end answer to be x equals something. So we can get rid of the minus 3 by adding 3 to both sides. Negative 3 plus 3 would cancel. We have absolute value of x on the left side, then 8 plus 3, or 11, on the right side. So we're not quite done yet because we have the absolute value of x equaling 11. So remember, absolute value means distance. So the distance from 0 is 11. So as a reminder, on the number line, if there's 0, the distance needs to be 11. So if I go to the right 11, that would take me to positive 11. So positive 11 is one of my answers, but I could also go to the left 11. So my distance would be still 11, but in the negative direction. That would take me to negative 11. So my answer would actually be positive 11 or negative 11. And I could double check by plugging the number back in. The absolute value of 11 would be 11, and the absolute value of negative 11 would also be 11, because absolute value makes whatever's inside positive.